Hello developers, welcome to Memos Tutorials. Today we are going to learn how to create custom validation annotations in Spring Boot. So without further ado, let's get started. First thing first, let's check how to create a new annotation in Java. As you all know, annotations are like metadata labels that provide additional information about the code elements such as fields, methods, or classes. They don't directly affect the behavior of your code, but they can be processed by tools, frameworks, or libraries. To simplify, you can imagine annotations as little sticky notes that you attach to your code, helping you to remember certain things, small details, or guiding processes. Creating an annotation is actually very similar to creating an interface. The only difference is putting the @ sign before the interface. And that's it. However, before using this annotation, you may want to customize it a little bit. To do that, you need to use annotations. There are two primary annotations you need to use. The first annotation is @target. This annotation allows you to specify exactly which kind of element this annotation is valid to be applied. If we go back to our sticky note example, with @target, you specify where you can stick this note because not all sticky notes belong everywhere, right? Some are meant for the top of your desk, while others are for your notebook or your monitor. You may not use it if you are okay to use this annotation anywhere, but in most cases, you want to define your target. To be able to specify the element, just type element type, and you can already see all the possible elements here. We have field, method, type, which is class, and so on. Depending on the usage, you can specify one or multiple element types. The second annotation is @retention. This annotation allows you to specify how this annotation is retained and utilized in different phases of the program's life cycle. Again, if we go back to our sticky note example, with @retention, you define how long these notes stick around because some are reminders only for tomorrow, while some are notes that you need to stock in your notebook until you graduate. Alright, almost every single time you will be using retention policy runtime because you want this annotation to be around while the program is running. But let's quickly explain the other two. Source is only there during the compilation phase. Once the code is compiled, these annotations are discarded and don't make it into the compiled bytecode. Class is present in the compiled bytecode, but it doesn't make it into runtime environment. One more thing before we start creating custom validation annotation is making annotation to accept the parameter. To do this, we just need to declare the needed parameter in the body of the annotation. However, we have to make it a method and not just a normal class field. Important note, you cannot just use any type you want as a parameter. It has to be a primitive type, a class type, or string, or an array of any of those. Also, you can add a default value if this parameter is not passed. If you don't specify a default value, then you are required to pass in that parameter when you use this annotation. Alright, now let's start coding some validation annotations. Imagine you want to exclude certain numbers from being accepted as an input. For instance, some numbers are considered unlucky or evil, so some people tend to not see or use them. It also differs from culture to culture, so you want to respect that as much as possible. Therefore, you want to exclude those numbers being accepted. So first, let's create our annotation. I will call it @ExcludedNumbers. As I explained before, we should add the initial annotations to our custom annotation. So we will set the target as field and retention as runtime. On top of these two annotations, we also need one more annotation to make it a validation annotation, which is @constraint. If you don't have this annotation, that means you don't have the dependency for Spring Boot starter validation. So don't forget to add this dependency. @constraint is like the link between your validation rule and the logic that checks it. When you apply your custom validation annotation on a field or a class, it makes sure that the appropriate validation logic gets executed. We can quickly check this annotation. You will see that it requires a parameter called validated by, and it accepts a class type that extends constraint validator. You cannot just pass any class here, and it doesn't have a default value. That means we have to pass it. So let's do that by passing a validator called ExcludedNumbers constraint validator that we will be creating soon. Also, I want to be able to pass some parameters in it. So here I will have an array of int called ExcludedNumbers. And that's basically it. Our validation annotation is ready. If you want, we can start writing our logic for the validation and call it a day. However, I want to mention 3 common methods often you will see in a validation annotation. The first one is message. This method allows you to provide an error message that will be displayed when the validation fails. You can either have a default value or expect it to be passed by the annotation. The second one is groups. This method allows you to categorize validation constraint into different groups. Groups are used to control the order and scope of the validation checks. By placing constraints into different groups, you can decide which constraints should be validated under different scenarios. In most cases, you can leave this as default empty array, which means the constraints belongs to the default group, or simply don't even provide and it will be placed in the default validation group. The third one is the payload. This method lets you associate additional payload information with a validation constraint. Payload data can carry extra information about the validation errors, such as its severity level or custom attributes. The payload data doesn't influence how the validation logic works, but it can be useful for adding more context to the validation error. Just like with groups, in most cases, you might leave this as a default empty array, or simply don't even provide and no additional payload data will be associated with the validation constraint. Alright, now let's write the logic of the validation. Let's create our ExcludedNumbers constraint validator class. Remember, addConstraint was expecting a class that extends constraint validator. So let's implement constraint validator. As you can see, this interface expects 2 things. One that extends annotation, and the other one is simply anything that we want to validate. So let's pass our annotation, and since we know that we want to validate only an integer value, we can pass integer as our validated element. As you can see, we need to implement some methods to make this validator work. If we have nothing to initialize, we don't have to override that method, but we have to implement isValid method, which will contain our logic for the validation. Since we are expecting an array of integer values, let's define it here too. In the initialize method, let's assign those values to our internal array to be able to use it further. Now let's write our logic. We want null values to be valid, so let's do that quickly. If value equals to null, return true. And now we want to go through the array, check each element to see if it equals to our value. If it equals to any of them, we will return false. If it is not equal to any of these elements, we will return true. To do that, quickly we can use Java stream non-match. So let's do that. Return int stream of excluded numbers non-match. Let's create our lambda num equals to value. And here we have it, our very own custom validation annotation. So let's use it. Here, I already prepared a simple REST call that gets a valid user request DTO, and if it is valid, it simply returns 204. Let's check our request DTO, and since we have the new validation annotation, now I want to validate the lucky number field and exclude those unlucky ones. According to the Wikipedia, these are the numbers that are considered unlucky, so I will just use them. So, as a responsible developer, let's write a unit test to confirm that this validation indeed works. As you can see, I already have a setup here. I won't go through the unit test setup, but you can find the repository that has this entire project in the description below if you want to check. So let's create our first test, should return 204. Let's create the request DTO, which I already prepared a valid one, and as you can see my lucky number is 7. So let's get this DTO, and now let's do a post call using mock MVC. We will perform a post request to this URL. Let's set the content type as application.json, and content will be our DTO, and of course we need to write it as a string. And as for the test itself, we will expect a status which is no content. Let's see if it succeeds. Now let's write a test to see if it returns a bad request. So let's create another test. Should return 400 when lucky number not valid. Let's get a valid request and manipulate the lucky number so that we are sure that it is invalid. And let's just copy paste the mock MVC call and change the expected status to bad request. Let's see if it succeeds. Finally, let's be a more responsible developer and write the unit test for the validator itself. Let's go to our excluded numbers constraint validator test. As you can see, there's a setup already. First, we need to implement a test version of our annotation, since remember it's an interface. Here, you can see that is fairly simple. Everything is default, nothing unordinary. Let's write the test should pass when given number not excluded. First, initialize the validator using the implementation that we created and pass the numbers that you want to exclude. Then, call the isValid method with a value and the mock constraint validator context and assign it to a variable to assert that it is indeed the result that we expected. So let's do that. Assert that result is true. Let's see if it succeeds. And let's check if it succeeds for the null value. Just copy and paste the first test and change the name and pass null. Let's see if it succeeds. Yep, another one. And finally, let's see if it fails. Copy and paste the text and change the name and pass an excluded number. And let's expect the result as false. Alright, so for fun and satisfaction, let's run all of our tests to see the test pass green everywhere. Now, let's create another validation annotation which is used on a class level and a bit more complicated than just passing an integer value. Imagine you want to have selective mandatory fields, meaning when one of the fields is present, it's enough to be valid, but when all of them are not present, then it is invalid. For instance, you want to get an identification from the user, but you want to give an option for it. User may provide an identification number or driving license number or passport number. It doesn't matter which one, but one has to be there. So let's create our validation annotation. Same things again, so let's just copy and paste the excluded numbers, call it AtLeastOneNotBlank, and change the target to type, which is class. Now we will be expecting an array of string to tell us which fields need to be validated. Let's quickly set the default message as well, and let's create the new constraint validator. Since I want to make it as generic as possible, I want to get an object as the validated class so that it can be used in any class, not just the request detail I created. Let's quickly initialize the validator and let's start writing the logic. Be aware that we will be playing with the reflection here. First, let's get the class itself. Since we want to check if any of the given fields have a value, let's iterate through the fields array. Then we need to get the field from the class that we just obtained by calling the getDeclared field. Then we have to make this field accessible so we can get the value of it. For the sake of simplicity, I will directly cast this value to string since we already know it. But if you want to make it really generic, then you should check the instance of the object before you cast it. And if the casted string has a value, then return true, because one having a value is enough for us. And of course, we need to try catch in case of the wrong type of casting or wrong field name, etc. And if nothing happens, return false. Okay, let's go to our user request detail and annotate our class and pass the fields that we want to validate. Fields are ID, passport, and driving license. Now let's go to our user controller test and run should return 204. It should still pass. And it does. And quickly let's set the ID as an empty string to see if it's gonna fail. Perfect, it fails because we are now expecting at least one of the given fields to be present. Now let's write a test when none of the fields are present to ensure it returns a bad request. Copy and paste the previous test and manipulate the request to be invalid. Run, and perfect, we got another green. Of course, as a responsible developer, we should write a unit test for the validator too. I will quickly do that off the screen since it is repetitive from now on. Now, for fun, let's write the final validation annotation for today's video, which is at Fibonacci. We will check if the given number is in the Fibonacci series or not. Let's quickly create the annotation and create the constraint. Of course, we will be using recursion to do that. I want to validate null values again, so if it is null, return true. And now let's write the isFibonacci method. So let's get the value and following two Fibonacci numbers. If our value equals to any of these, then return true. If not, let's check if the sum of these two numbers is bigger than our value. If it is bigger, then it means that our value is not in the series, so we can return false. And of course, let's call is Fibonacci with the new numbers. This should do the job, so let's quickly test it. Add it to the request, copy and paste one of the tests and change the values, and let's see if it returns a bad request. It does. Nice. And there we have it. That's custom validation annotations for you. I hope you enjoyed it and learned something new. Once more, you can find the link to the repository in the description below with many more validation annotation examples. Thank you so much for watching. Until next time, happy coding!